Welcome to Section 3, Bioengineering the Solution. In this section, we will transition from the biological blueprint, the way our bodies are naturally built, to engineering the prototype. We will explore how engineers take inspiration from nature to design and build functional replacements for the human body. The history of prosthetics is a story of material science. What we build with determines how well a prosthetic works. Originally, wood was the primary material. While it provided structure, it was heavy, rigid, and had a tendency to rot or rust over time. In the 1900s, we moved on to aluminum. This was a huge leap forward because it was much lighter than wood and far more durable, making prosthetics easier to wear for longer periods. Today, we often use carbon fiber. It's a material that's extremely strong and even lighter than aluminum. Finally, we use modern additions like titanium or specialized plastic for joint components. These materials are incredibly tough and allow for smooth, precise movements needed in modern prosthetics. When we design a prosthetic arm, like the one you see here, we aren't just building a machine. The body is the blueprint. Every mechanical part you see has a biological equivalent. For example, the hard plastic or metal frame acts like our bones to provide structure. The cables and motors act like our tendons and muscles to create pull movement. Even the sensors in the fingertips are designed to mimic our nerves and sense of touch. By understanding how the body works, we can engineer solutions that feel and move just like the real thing. A big part of bioengineering isn't just making the best technology, it's making sure everyone can use it. On the left, you see a high-tech robotic arm. It's amazing, but it costs between $70 and $100,000. That's more than most people earn in an entire year. Because insurance is often inconsistent and because of the high price, almost no one in developing countries can afford this kind of help. On the right, however, we see a different kind of solution. This is a open source 3D printed hin. It only costs about $30 to $50 to make. Because the designs are shared for free online, local engineers anywhere in the world can download them and customize them exactly for what a person needs. Good engineering means creating solutions that everyone can access, not just those with a lot of money. Now that we've seen how engineers use materials and biological blueprints to solve problems, it's time for you to step in the role of the engineer. Take a look at the 3D printed prosthetic on the screen. It's lightweight, affordable, and functional. Today you're going to explore how this kind of device works. We want you to look at these components and think, how did these pieces move? How do they mimic a human hand? And most importantly, how would you put it together to help someone in need? Let's get you to work on your prosthetic. Thank you.